So we're going to follow the same steps we did in the last example. We're going to go ahead and factor the top and the bottom completely separate, and then we're going to look for things they have in common. You have to factor first. You cannot pick and choose different pieces and say, but there's a -6 and a -6. No, there's not. You're a liar. There's not a -6 and a -6. There's a 3x minus 6, and there's an x squared plus x minus 6. Those are not just standalone numbers. So, let's factor. The numerator, 3x minus 6. Do those terms have anything in common that I can take out? They definitely have something I can take out. I'm just looking on the top. 3x minus 6. Raise your hand if you can tell me. What do they have in common? What am I going to take out here? Ryan? 3. So they both have multiples of 3. Let's take that out. That's going to leave me with x minus what? 2. Remember, when you factor out a number that they have in common, you're dividing everything by that number. So 3 divided by 3 becomes 1x. 6 divided by 3 becomes a 2. Now, here's where things are a little bit different from the last example, so please pay close attention. In the denominator, they don't have anything in common, but this can be factored. This can be factored in a way that we have done over and over and over and over, and we will continue to do over and over and over and over. Does anybody recognize what type of polynomial I have on the bottom here, and what type of factoring I should do with it? Spencer? This is a quadratic trinomial. We just finished a whole chapter on quadratics. How do we factor if we have a quadratic? What method do we use? X method. So, underneath or off to the side somewhere, we're going to go ahead and set up the X method. I am multiplying to make -6, but I am adding to make +1. Can somebody raise your hand and tell me the two numbers that will accomplish this? Savannah? -2 and +3. Now here's where we usually run into a problem every year. When we were solving a quadratic, we're not solving, we're simplifying now. If you solve a quadratic, you stop here and you say, oh, my final answers are +2 and -3, right? That's the shortcut we had. We are not solving right now, so don't do that. We have to use these numbers to make binomials. So, in case you have forgotten how that works, this would be 1x minus 2 and 1x plus 3. Alright, so we have factored everything. Everything that could be factored has been factored. Now, we look for things that match. And even in this problem, there is something that people tend to make mistakes with. One of these things should be really obvious of what you should do. One of them's a little more subtle, and it's something you shouldn't do. So can someone raise your hand and tell me, what is the obvious thing that I should be canceling at this point? Two things definitely match up entirely. We have two factors, one on top, one on the bottom, that match perfectly. And I should be getting rid of these. Timing? X minus 2. I have an x minus 2 on top and an x minus 2 on the bottom. Those binomials matched completely, which means that I'm going to go ahead and cancel them. Does anyone see anything else that they believe I should be canceling here? Spencer? The 3's. This is wrong, but it's a very common assumption. Here's where we got to go back to understanding what is and is not allowed to actually be canceled. The 3 that I have on top is just a constant. It's a 3, completely by itself, that I had separated from this polynomial on top. But this 3 down here, this 3 on the bottom is not just a constant. This 3 down here is part of a binomial x minus 3. The only way I would be able to cancel this 3 on the bottom is if I had an x plus 3 on the top. So we can't pick and choose parts of factors. We have to do entire factors at a time. So the 3 and the x plus 3 can't actually cancel each other. So we're going to go ahead and just say this is it. 3 over x plus 3. And some people might say, well, that doesn't seem very helpful. I thought it was supposed to reduce down to a number. This is still pretty helpful. No matter what number you choose, and we'll talk about the exceptions in a moment, no matter what number you choose, if you plug it into the original problem for x, it will be the exact same thing as just plugging it in once here for x. This saves you a lot of work. If I tried to plug in a number like 5, it's much quicker to just do 5 plus 3 and get 8 and know that this will be 3 over 8. Instead of plugging in the 5 here, here, and here, and doing 3 times 5, then subtracting 6, doing 5 squared, then adding 5, then subtracting 6, and then reducing it to eventually get 3 over 8. So we have simplified this process a lot. You now are only doing one thing, adding 3 to it. And that's it. Then you get your fraction answer. Now, we have exceptions. Exceptions don't always exist, but they usually exist. So let's go back to talking about the excluded values. To find the excluded values, we tell ourselves the denominator cannot equal 0. That's not allowed. Which means that I'm going to take the original denominator, x squared plus x minus 6, and I'm going to try to find out what numbers would normally make that equal 0. What numbers do I not want? Some people get a little confused here and they say, well, we can't solve this. It's got an x squared in it. If I add 6, I'm stuck. There's nowhere else to go. We just did a whole chapter on this. I can solve this quadratic for 0 using any of the 3 methods I want. I can factor it. I can use the quadratic formula. I can use completing the square. One of these methods is obviously way better than the other 2. Who's got an idea? Spencer? Completing the square would probably be the worst idea for this one. No, we'll explain why. You can use any method you want, you will get the answers, but I'm going to explain. One of these methods is so much better than the other ones, and there's a really good reason why. So we're not going to use completing the square, but you could if you would like. Savannah? Why do you think factoring is better than the others? It does get the answers faster. There's an even better reason. So factoring is the one we're going to do, but there's an even better reason why we should use factoring for this. William? We already did it. That's the good answer. So the best possible scenario, we already factored this. Didn't we have to factor it to do all the simplifying? Well, if we've already done it, don't do it again. Good grief. Save yourself some time. We already factored this. And, I mentioned earlier, there's already a shortcut for this. If I factored this already, and these are the numbers that I got while I was factoring, then I know for a fact, because we just did this last chapter, that the numbers that would normally make this equal 0 are positive 2 and negative 3. Now, if you do not want to do it that way, if you really want to go through because you are just more comfortable using completing the square or using the quadratic formula, you can do that. It will just take you a little bit longer than it will everyone else because we have already factored this. So, putting all of this together, when you simplified this, it will simplify down to 3 over x plus 3, but x cannot equal 2 or negative 3. And all of this together will be our final answer.